Good afternoon. Welcome back to the chemical equilibrium. Yesterday we have seen the effect of pressure, temperature, and concentration on equilibrium constant. And whereas the catalyst also we have seen. Now we will see what is actually catalyst. 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 Okay. It is any compound type, but it first it does not participate in reaction. This is the first. It does not alter Kc, equilibrium constant. But what will happen? It alters rate of reaction. This is the catalyst activity. So most of the people have a wrong idea or wrong concept. Catalyst means always it will promote the forward reaction. No, there are some catalysts which reverse the rate of reaction. That means positive catalysts are there, but we normally generally use the word catalyst means increasing the rate of reaction for forward reactions. But actually whenever a question comes in the MSETs or any NITs or anything, correct answer is it alters is the correct one. Not only the forward reaction, not only the backward reaction, it alters the rate of reaction. That is the one. Fourth, last important, it cannot be shown in balanced equation. It should not be shown in the balanced equation. That is the. Then what it is doing actually? It is lowering the potential energy. That means the path. It takes the low energy path for the reaching the products. It lowers the pathway for the conversion of the reactants into the products. So now coming back to the again our equation, nitrogen plus 3 hydrogen gives 2NH3. We have seen this is an equilibrium. Here we require high temperature, high pressure. Agreed, high pressure. That is around 200 atmospheres or bar, whatever. But this is a favorable because the right side it is lower number of molecules, but low temperature is favored, but we are using high. Low temperature is favored, but what we are using is around 500 K, because at this low temperature the rate of reaction is slow. So what we are doing, we are adding catalyst like iron and promoter like molybdenum. Iron is a catalyst, molybdenum, and using at high temperature so that you will get a good product in the industrial scale. Industrial scale there will be small changes like this, because we want the product more faster and the higher product rates and yields and all these things. So similarly so many things and all. So that is about the catalyst. So don't get confused with the catalyst and this thing and all. Fine. Now before going to the acids and bases, we'll say you keep a sugar water and try to pass the current on in this. It will not pass. Take another beaker, another spoon of the one more in another this thing. Prepare a aqueous solution of the salt water. Try to pass the current. It will pass. Then what is the difference? The first one is a sugar solution, second one is a salt solution. In the sugar solution, current will not pass, whereas in the salt solution, current will pass. The first one is called, the second one is a salt solution. Salt solution is called electrolyte. whereas sugar solution is called non-electrolyte. Again, the electrolyte, there are strong electrolytes and weak electrolytes. Means ions and this thing. So in detail, to see what are the strong electrolytes, what are the weak electrolytes, why the non-electrolytes, all these things. So to check first, we have to go through the acids, bases, salts. So general there are so many definitions and all, where there are three theories. First fellow is Arrhenius. Second fellow is Bronsted, Lowry. Third fellow is Lewis. Like this, three theories are there on acid basis. Okay. So now, but normal what we are see interestingly in the stomach, whenever regularly if you are eating at particular time, lunch or the breakfast or whatever it is, in a day around 1 to 1.5 liter hydrochloric acid will generate to secretions, through secretions because for the digestion. So that is an acid. So one should know about the lime water or the any other they are within sour taste. Soap we know that is in the slippery this thing and all this thing. So one should know the concepts of the acid and alkali. So according to Arrhenius, one substance which gives H plus ions in water is acid. As per Arrhenius, substances which gives H plus ions in water is acids. Substances which gives OH minus ions in water are bases. As per Arrhenius, if I am dissolving in a substance, if it is giving H plus ions, that is an acid. If I am giving the OH ions, so examples he has taken: hydrochloric acid in the water gives H plus ions. So this is acid. Similarly, NaOH in water gives OH minus ions. So it will give, it is NaOH is base. That is as per Arrhenius. But so as per him, substances shall have the H plus ions and OH minus ions in the water. That means it is limited to the only water he is as per. So further theory has developed. Further theory, and he is not able to explain ammonia whether it is a base or acid or whatever it is and all. So Bronsted theory has come. The next phase means that is the improvement. What he has told, Bronsted, one which is giving, donating H plus ions. Bronsted theory is Bronsted, Lowry theory, acid base. As per him, what he is telling, acid is a substance that gives H plus ions, that gives H plus ions or that donates H plus ions. Acid is a substance that donates H plus ions is acid. Okay. Whereas the one which is taking H plus ions is a base. The one which is donating is acid. The one which is accepting the H plus ions is a base. Here he is not talking about the OH. So it is broadly more improvised than the Arrhenius. Acids are substances which donates H plus. The bases are substances which receives or accepts H plus ions. So as per him, ammonia means, because ammonia, you take ammonia. As per Arrhenius, neither in the water it is not giving OH ions or anything. Whereas now here is ammonia, if it is added to water, is in equilibrium with ammonia ion and OH minus ion. So here ammonia is a base. Ammonia is a base. Ammonium ion is a conjugate to acid of this base. Interestingly, H2O is acid. Here, interestingly, H2O is acid, and ammonia is a base. This is a conjugate to acid. This is a conjugate to base. Conjugate to base of the water, OH. Conjugate to acid of the ammonium ion is the ammonia. Similarly, one more example we'll take HCl plus water. If you take H3O hydronium ion and chloride ion, here there is no OH, but whereas H is giving electron, HCl is giving H plus to H2O, so this is acid. This is acid. This is a conjugate to base. And H2O is here base. You see, in each case it is changing. In ammonia case, that is H2O is acid. In HCl case, ammonia is a base, water is a base. So water will act as a sometimes acid, sometimes base. So its oxidation numbers also, oxygen numbers also is varied, and all these things we have seen. Tomorrow we will see the some other examples and Lewis acid base theory. Interesting, these things will come in only when pH is coming into line and all these things. Okay, thank you.